Hello, Big Data LDN. I'm Steve Wilkes, CTO of Striim. I'm so happy to be with you for my third year at Big Data LDN. We at Striim have been focused helping our customers with cloud adoption, and I'll be sharing some of what we've learned in this presentation. I'll stick around afterwards to answer questions, but you can also communicate via the Engage tab or visit our virtual booth to chat with me and my colleagues. And be sure to watch the presentation from Alok Parikh tomorrow at 2:45 p.m. where he'll be discussing best practices for real-time data integration for BigQuery analytics. I hope you enjoy the presentation. So how can fast data help minimize the risks of cloud adoption? In this presentation, I'm going to talk about why cloud adoption is important and what challenges are being faced. Specifically, I'm going to focus on the risks faced when migrating data to the cloud and how zero downtime migrations utilizing change data capture can help with that. I'm going to do a quick demonstration of how the Striim platform can help with cloud data migration and talk about some of the other problems real-time integration can solve. After a few customer examples, I'll open things up for a Q&A. In the current business climate, digital transformation has become vital for survival. With more employees working remotely and physical interactions with customers restricted, it's become essential to provide operational efficiency, optimize costs, and scale both up and down as necessary. Adopting cloud technologies is a really important part of this transformation, but is not without its challenges. Gartner cites cloud as one of the top 3 game-changing technologies. And if you look at the other important technologies, most, if not all of these, will be performed in the cloud. This means that the data required for machine learning or analytics will also have to somehow make it to the cloud. There are many ways in which organizations are looking to adopt cloud, but unless they're a brand new company, they have to consider the existing on-premise applications and data. Adopting a cloud platform will typically involve some degree of data migration or continual integration from on-premise to cloud. And a good proportion of companies will utilize multiple clouds for redundancy purposes or because of a specific technology requirement. Organizations may also switch clouds due to economic or other reasons and move data between clouds to synchronize databases or applications. However, Gartner has determined that the number one risk to cloud adoption is the worry that data will be lost or somehow compromised, with 36% of companies realizing that that is a challenge. That's not really surprising, though, given just how important data is to organizations. Interestingly, Gartner also identified lack of cloud migration tools and processes as a key problem. And hopefully, what you see today will help alleviate some of those worries. Things are further complicated by the changes in technology in moving from on-premise to the cloud. Database migrations may not be like for like, moving an on-premise Oracle database to Cloud SQL for PostgreSQL, for example. And the analytics environments are very different from what may have been used or considered on-premise. Organizations also have to consider the different ways that cloud platforms handle security, resource management, and which technologies are available where. This puts huge pressure on teams performing data movement due to complexities in technology variance, data volumes, and latency requirements. Which brings us to the main topic of the presentation. What are the common risks in cloud data migration and integration, and how do you mitigate them? How do you move data from on-premise to the cloud without taking any downtime for existing applications? How do you reduce or completely eliminate the possibility of data loss? How can you perform sufficient testing of your new cloud environment to make sure it's working before you cut over? How can you ensure that the cloud has the most current data all of the time? And how do you do all of this in a secure fashion? The main thing to consider in migrating applications to the cloud is that the conversion of application itself to cloud-native technologies is only half the story. A bigger and more complex question is how do you migrate the data required to power the application? The first thought may be to bulk load the data from on-premise to the cloud. This requires downtime, since a bulk load is moving data at a point in time, and the source data shouldn't change from that point on. but moving large volumes of data to the cloud can take a long time, and most enterprises can't afford that amount, if any, downtime in their critical applications. And if you don't take downtime and the application continues to run on-premise, the data will change during this loading process. Those changes would be lost when switching to the cloud. Moreover, some migration tools can lose data during failures, requiring a complete restart of the process and really thorough testing. It can take some time to quite thoroughly test the migrated applications. This could be weeks or even months. The on-premise application can't be down the whole of that time, which means the original data will change a lot. And if you don't test the application sufficiently, you can have severe failures down the road. Obviously, cutting over to the cloud is impossible in this scenario. The whole data migration would have to happen again after testing is complete. So how do you then verify that the migration is successful without further testing? The most important cause of these problems is the inability to take downtime, coupled with the time required for testing. The source data will constantly changing during testing and beyond, especially if a phased cutover of users from on-premise to the cloud is required. This means the cloud requires constant refreshes of data to prevent staleness, which further complicates the migration and testing procedures. The final consideration is ensuring security during this process. All connection information and any data stored, even briefly on disk as an intermediary stage in the migration process, requires encryption. Crucially as well, all data sent over any network, whether public internet or private cloud connection, also requires encryption. Security and the risk of data theft is a critical piece of any cloud adoption strategy and cannot be taken lightly. In summary then, the 5 major risks and challenges we're going to try and solve are: how do you reduce or eliminate downtime? How do you guarantee no data loss? How do you provide time for adequate testing? How do you continuously feed new data? And how do you secure endpoints and network data? The key to solving most of these problems involves a combination of an initial load of data coupled with ongoing change data capture and real-time change delivery to the target system. This enables the source systems to stay active for transaction processing and also allows an immediate switchover to the new cloud application, and thorough testing is carried out with live data. This enables you to move data to the cloud without having to take application downtime. It can prevent data loss by validating data delivery to ensure database consistency. It can minimize the risk of a cutover by providing enough time to completely test the cloud application, and allows for cutover back to the legacy system in case of failure if you reverse the flow from cloud back to on-premise after the switchover. Change data capture, or CDC, is a low-impact way to collect changes occurring in databases without affecting the source system. You might think about databases as a historical record of what's happened in the past, but a database supporting an application will be constantly updated through DML operations. These changes are written to a transaction or redo log, which the database uses for recovery purposes. CDC collects these changes as they occur and turns them into events. So every insert, update, and delete in a database becomes an equivalent event in a real-time integration platform. When you combine CDC with an initial load, you can eliminate downtime of the source application. First, you start CDC to record any changes that are going to happen. Then you do the initial load. Once the load is complete, you apply any changes that happen during the load to the target system. You can also then continue to apply changes to enable thorough testing. Of course, CDC by itself isn't enough to eliminate all of the risks. You also need exactly once processing, or E1P, to prevent data loss, as well as continual feeds to not only enable testing, but prevent data staleness in a phased cutover scenario. And of course, security and encryption of data is required end-to-end during initial load and change delivery. I'm now going to show you how Striim can be used for cloud data migration. Striim is a real-time data integration platform, enabling enterprise data movement to the cloud to help drive digital transformation. Our customers are using our platform for initial cloud adoption, moving data to the cloud for new applications and reporting, and continuously feeding cloud analytics and machine learning. In this demonstration, you'll see how customers use our wizards and UI to create a data flow from Oracle to Google Cloud SQL for PostgreSQL. We'll show you how CDC works and also how you can do an initial load from Oracle to Cloud SQL. Then how our customers can monitor the data flow while that migration is happening. Performing streaming data integration with Striim starts with our wizards. We'll select Oracle as a source and Cloud SQL for PostgreSQL as a target. When you click on the wizard and you enter a name for that data flow, you need to complete a few simple steps. First, you configure the source. Enter all the necessary information to connect to the source and click on Next. Any secure information like passwords is going to be encrypted. Then it's going to check to see that the connection is correct and you have correct permissions and it supports change data capture. Once you've done that, you select the tables that you're interested in collecting data from. You can change this selection afterwards, so just choose a few tables initially. Then you configure the target connection information, including how the source data is mapped into the target tables. When you complete the wizard, a data flow is created, and you can see the source and the target configuration here. To start the data flow, first you deploy it to get it ready to run. Then you start it to begin collecting data from Oracle and delivering it into Cloud SQL for PostgreSQL. Initially, there's no data flowing because we're not generating any new data in Oracle. You can see from the UI for PostgreSQL that there's no data in the target tables. Now, if we run a data generator for Oracle, it's going to create some inserts, updates, and deletes. You can see this data in the data flow preview window and see the rate of collection in the UI. And you can also look at the application progress, see a summary view of the tables. Once some operations have been generated, we can check back with the Cloud SQL for PostgreSQL UI and see the data in the target tables. Of course, Striim can also perform initial loads through similar data flows. Here, moving 1 million rows from Oracle to Cloud SQL for PostgreSQL, and you can monitor the progress for the Striim UI. If we switch to the Cloud SQL for PostgreSQL UI, you can see the data in the target as well. You can also use Striim to monitor data flows, overall metrics, and drill down to see the application statistics and very detailed information for each of the components in that pipeline. The Striim platform is not limited to just databases or just doing migrations. We support cloud databases, data warehouses, messaging systems, storage, and services in Azure, in AWS, Google Cloud, and we can also deliver real-time data to Snowflake on any of these clouds. In addition to database sources, we can also collect real-time data from messaging systems, logs, sensors, and more, and continuously deliver that data in real time to any of the targets I mentioned before. Using Striim, customers can process the data as it's moving to drive new value from existing legacy systems. I'm now going to show you how Striim has been used by our customers for cloud data migrations and integration. This global delivery company is using Striim for hybrid and multi-cloud solutions in warehouse management. By delivering data from an Oracle database, supporting an existing warehouse management system to Azure SQL DB, and integrating a supply chain solution database running on Amazon RDS, also to Azure, they've been able to reduce the latency for warehouse management operations and analytics from 15 minutes to real time, which is really important in an environment where the global reduction in brick and mortar sales has resulted in a drastic increase in the amount of items being shipped. And this leading retailer is also seeing the effects of a change in the way people shop. Cloud is essential to scale the online retail business as more and more people buy things online. By using Striim to move real-time transactions occurring on a mainframe to Google Cloud, they're able to finally get real-time visibility into inventory and orders, positioning them to rapidly respond to customers and provide accurate information at the busiest of times. A major North American bank is utilizing Striim to power cloud-based reporting and analytics. the bank has instituted a cloud-first policy for all new applications, but most of their existing financial systems are on-premise. These legacy and mainframe-based systems aren't suited to the new types of applications and reporting required for today's business. So by collecting data from the on-premise systems and delivering to Azure, the organization can get real-time insights into financial reporting and analytics. This credit agency wanted to streamline the employment verification process as part of any credit check. When applying for loans, one of the first steps is to validate employment, which involves collecting payroll information from many vendors. By utilizing real-time data collection from their own databases and files provided by third parties when employment changes happen, they could be sure that the information they have is always up to date, and the verification process can happen really quickly. This speeds up the whole loan origination process for the lenders that rely on them and offers a better experience for borrowers. The final example is a healthcare provider that wanted to transform the way they built business applications. Instead of having a lot of point-to-point integration to move the data between applications and to partner systems, they built a cloud-based event data hub from which all future applications could be built. By collecting real-time data from their existing infrastructure and transforming and encrypting the data in flight to their canonical model, they're able to provide a platform on which business applications can be built for their customers and their partners. This not only makes building and maintaining applications faster, but also has built-in data governance and protection. By adopting a platform like Striim for cloud migrations and integrations, you can solve the numerous challenges we posed at the beginning. CDC can be used to capture and deliver changes during an initial load to eliminate source application downtime. Striim's exactly once processing capabilities in the case of failures and restarts can guarantee delivery to eliminate data loss. By keeping CDC running after the initial migration, you can plan sufficient time for adequate testing. And by continuously feeding new data to the cloud, you can eliminate staleness, not just for the migration, but for other targets as well. And of course, Striim provides enterprise-class security and data encryption to safeguard your information throughout this process. Hopefully, you've enjoyed this presentation. I'll now open things up for questions. As I mentioned, you can also use the Engage tab to communicate and visit a virtual booth to talk to me and my colleagues. And be sure to watch the presentation from Alok Parikh tomorrow at 2:45 p.m., where he'll be discussing best practices for real-time data integration for BigQuery analytics. Thank you.